Alrighty, 2.3 day 2. You'll see the same theme here that we're trying to work on making connections between the structure of polynomial equations and their graphs. Okay, and today we're going to just attempt to look at a picture of a graph just like this and come up with the equation of the polynomial that represents that graph. Okay, a couple things to notice first of all here. This is a degree 2 polynomial, which means it's a quadratic. I see it's got 2 x-intercepts, and that is really where I'm going to kind of start the process here. It's got an x-intercept at x equals 2. It's got another one at x equals -4. Down here, looks as though it's got a y-intercept of 0, -3. Okay, and that's about all I can tell about the graph so far. At least that's all I'm interested in. Now I'm going to use the x-intercepts to kind of make the jump to the equation. Okay, now I should mention at this point in time there's a value for a that I don't know. Okay, though I should mention here that this is a parabola that opens up, and a controls the direction and the width of the graph. I'm going to have to do some work in a few steps here to get the width, but from looking at the graph, because of the fact that it opens up, I can tell that a is going to be positive. Okay, so I'm going to factor that in when I start to find it. If I don't get a positive number, something went wrong. Okay, so it's kind of a means to think about what we're doing and reflect on our answer and make sure we're on the money. Okay, so I don't know a, though I know it's going to be positive, but other than that, I don't know it. But here is where I can really make the jump to an equation. On the graph, I saw it had a 0 of -4, which means it has a factor of x plus 4. Had a 0 of 2, which means it'll have a factor of x minus 2. All right. Well, this is actually a pretty big step towards getting my equation. I've got 2 factors, and this is a quadratic, so it's degree 2, and that means I should have 2 factors, and I got them. And now it comes down to finding a, and that is where this y-intercept is going to come in quite handy. My goal here is really to find a, but from that y-intercept, I know if I plug in 4 for x, y must be -3. Okay, because that's a point on the curve. If I put in 0 for x, it gives me -3 for y. Now if I simplify this a little bit, 0 plus 4, 0 minus 2, I can work my way down here, and in not too long, I'm going to divide both sides by -8 here, and not too long, I can see that a is 3 over 8. Okay, notice when I divide here by -8, the negative signs cancel, which is why it's positive 3 over 8, which is consistent with what I thought at the beginning, that a needs to be positive. I'm going to go ahead and leave my final answer in factored form. Though I do want to mention at this point, if the directions for a problem were picky and said, hey, you got to switch it to standard form, it would just be a matter of distributing the 3/8 over the x plus 4 and then foiling. Okay, it wouldn't be terrible. I'm not concerned about it right now because that's really not the biggest issue in terms of what we're doing. If you can get it to this point today, oh, I'm happy. Okay, I'd be happy with that because that is the equation. It just happens to be the equation in factored form. Okay, here's another example. Pretty similar problem here, but notice I no longer have a quadratic. Rather, I have got a cubic. This is degree 3. And just as a review from some of the behavior of the graphs, okay, what's given away that it's a cubic is those tails going off in the opposite directions. Okay, so this polynomial is degree 3. That becomes very relevant for finding the equation because this one looks very similar in the sense that I'm going to use its x-intercepts, which I can see at 3 and 1. I'm going to use those to get the factors. And one thing I do notice here is it does not have a y-intercept clearly marked, which could be a bit of an issue. But we'll deal with that when we get to it. Right now, let's jump to the equation using the factors. I still have to worry about that leading coefficient a, which again controls kind of the shape of the graph, whether it's a really skinny cubic or if it's a really wide graph. I notice here the left tail goes down and the right tail goes up. That tells me that a is positive, so I'm going to factor that in as well. I should be expecting a positive value for a. Oh, it's got a 0 at 1, which means it's got a factor at x minus 1. It's got a 0 at 3, which means it's got a factor at x minus 3. Now, something to note here, this is a third degree polynomial, which means it has to have 3 factors. Okay, 3 linear factors. I see 2. I see a linear factor of x minus 1. I see a linear factor of x minus 3. Okay, this cubic has to have 3. Okay, what's going on here is this x-intercept right there at x equals 3. It's an x-intercept because it touches the axis, but notice how it doesn't cross. Okay, the graph does not change signs. It's a positive graph, meaning it's above the x-axis. It comes down and touches the graph right at x equals 3, and then it heads back up again. Okay, whenever that happens, we have what's called a double zero. Okay, and that means that x minus 3, suppose you can barely see that. Try to write it in here so you can see it. That factor of x minus 3 is to the second power. Okay? Now I'm going to keep moving here and try to find a, because I've now got the factors written out correctly. And I don't have the y-intercept, and that's okay. There was actually nothing special about the y-intercept. I didn't need it. What I really need to have is I need another point on the graph. And it doesn't have to be a special point. Any point will do. I just want to make sure it's very clear that the graph goes through that point. Looking at the top of that maximum right there, it looks like this graph definitely goes through the point 2, 2. So now to find a, I'm going to plug in 2 for x. I'm going to plug in 2 for y, and again it puts me in this situation where I can solve for a, and I'd have everything I need for my equation. Notice my means of solving it. Very, very similar. I'm just simplifying everything that's over here on the right. That becomes a times 1, which is just a. So a is 2. So for a final answer, y equals 2 times x minus 1 times x minus 3 to the second power. And that represents the equation of that cubic polynomial. Okay, and again, this form is fine for a final answer. It would require quite a bit of distributing to switch it to standard form. And again, I just want to make note, I don't want to take the time to work through and do it, but just to note that that's what you'd need to do if you ever had a problem that asked you to put it in standard form. All right, let's look at one more. Okay. Now, if you're feeling good about everything, this may not be a bad time to pause and take a peek and see if you can, figure this out on your own. If not, let's work through it together. First thing I notice here, this is a degree 4. Both tails are going down, so that tells me A, which just like the others, I'm eventually going to find. It's going to be negative. It looks like here we got a x-intercept at -1. We've got one at 1. And we've got one at x equals 2. So y equals A times a factor of x plus 1. That again is coming from this x-intercept at x equals -1. X minus 1 coming from the factor of positive 1. And x minus 2. Notice I have 3 factors there. Okay, can you find the one that's a double zero? Because again, that's what's going on. The x plus 1 is the double zero because that is this x-intercept that approaches the axis, touches it, but goes back down. Looks like I do have a y-intercept. Again, it's nice when I have the y-intercept because that's an easier point to work with, but like the previous example that we did with the cubic, it doesn't have to be. Okay, we just need an additional point. Again, I'm looking for A. Plug in 0 for x, 0 for x, 0 for x, yet again. Put in 0 anywhere you see an x. When I do that, I get -3 for y. And once again, our final steps are just about moving forward here and solving for A, which I'm expecting to be negative. It's worth noting. 1 times -1 times -2 is +2. Divide both sides by 2. Oh, look, there you have it. Indeed, A is negative, which is why the graph opens down. And just to finish this one off, -3/2 times x plus 1 squared times x minus 1 times x minus 2. That would be a distributing nightmare that would actually take more time than you'd probably think. Even if you think it would take a lot of time to FOIL that, it would probably be even more. So that answer's fine. That's a factored form of that 4th degree polynomial. Represented by that graph. All right, so you got 3 good examples, one with a 2nd degree, one with a 3rd, one with a 4th. And again, what I'm really hoping you see here is the similarities, that it's really about using the zeros to find factors, using an additional point to find A. Regardless of the degree, that's what the process is really all about. Okay? Make sure you write down any questions that you have and be sure to ask those as soon as we see each other again in class.